coaching center. So today I'm going to explain your 12th standard physics 12th chapter, that is dual nature of radiation and matter. So introduction. So the discovery of X-ray by Röntgen in 1895 and of electron by J.J. Thomson in 1897 were the important milestone to understand the atomic structure. It was helpful for us. So they both explained about that. Next, so Thomas was first to determine the experimentally the speed and the specific charge of the cathode ray particle, and they were found to travel with speed ranging from about 0.1 to 0.2 times 0.1 to 0.2 times the speed of light into light 3 into 10 to the power 8 meter squares, and the presently accepted value of em is the electromagnetic is 1.76 into 10 to the power 11 kg, and the material used as the cathode or the gas introduced in the discharge tube. This observed suggested the universality of the cathode ray particle, and in the same time in 1887 it was found that the certain metal when eradicated the certain metal when it is eradicated by ultraviolet and emitted negatively charged particle having the small speed when it was found when it was found, and then the J.J. Thomson in 1887 named the particle as electron and suggested that they were, and he found a particle and he named the particle as electron and suggested that they were fundamental universal constituency of matters. It is the constituency of matter, and he was awarded the Nobel Prize in Physics in 1906. And in 1913, an American physician who is R.A. Millington performed a pioneering oil drop experiment for precise measurement of the charge on an electron, and he found that the charge on an oil droplet was always an integral multiple of an elementary charge 1.602 into 10 to the power minus 19 c. He found that the charge is perpendicular is equal. He found that the charge that is found is the multiple of the old charge. Next is electron emission. So free electrons that are responsible for the conductivity, uh, and however the free electrons cannot normally escape out of the metal surface. If an electron attempts to come out of the metal, the metal surface acquires the positive charge and pulls the electron back to the metal. It does not leave any electrons to go out of the metal, and 1 electron volt is the energy gained by an electron when it has been accelerated by a potential difference of 1 volt. So 1 ev is equal to 1.602 into 10 to the power minus 19 joule, and this unit of energy is commonly used in the atomic and nuclear physics, and the work function depends on the function of some metals are given in table 11.1. Here they have given about its work function. So first there are three emission, that is thermonic emission. So by suitable heating, sufficient thermal energy can be imperated so to the free electrons to enable them to come out of the metal. So by using the heating and thermal energy, we can do a thing to help the electrons to come out. So that is called as thermonic energy. And thermonic emission, and field emission is by applying a very strong electric field to a metal, electrons can be pulled out of a metal. So by using a very strong electric field, we can pull the electrons from the out of the metal. That is called as field emission. And photoelectric emission, when light with suitable frequency illuminated or sent into metal surface, electrons or can come out. Then it is called as photoelectric emission, then it is called as photoelectric emission. So these are the three types of emission: the thermonic emission, when it is heated and suitable sufficient thermal energy when we give, the free electrons come out. And field emission, when strong electric field is sent into it, the electrons come out from the metal. And when a light is sent into the element, the electrons come out from the metal, then it is called as photoelectric emission. So these are the three emissions. Next is photoelectric effect. So there were two scientists who observed on this. One is Hertz. So Hertz observation. So during electric wave experiment, in this experimental investigation on the production of electromagnetic waves by means of speed discharge, Hertz observed that the high voltage sparks across the detector loop. So he observed, after finding electromagnetic wave, there was a high sparks across the detector loop were enhanced when emitter plate was illuminated by ultraviolet light from an arc lamp. So light shining on the metal surface somehow facilitate the escape of free charges particles, which we now known as electron. So the charges particle came out, which we now known as electron. When light falls on the metal surface, some electrons near the surface absorbs the light energy, and after gaining sufficient energy from the incident light, the electron escape from the surface of the metal. So after getting the energy, the sufficient light energy they need, they come out from that metal. So like this, Hertz observed the photoelectric effect. That is, photoelectric effect means when the light is put on, the light fall on it, they when light fall on it, they observe that, and the electrons come out from that metal. The Hertz observed. Next is the Hallwitz and Leonard observed. So how they both observed means, so the observation indicates that the ultraviolet reaction falls on the emitter plate C, and electrons are ejected from it, which are attracted towards the positive. So they observed that the electrons come out from them and attract towards positive collector plate A by the electric field, and the electrons flow through a evacuated glass tube to a glass tube, resulting in current flow. So that result in current flow they observed. Next is the experimental study of photoelectric effect. So photoelectric plate, that is C, and another metal A, monochromatic light from a source S of sufficient short wavelength passes through a sufficient short plate, that is short wavelength passes through a window W and falls on the photosynthesis plate, that is denoted by C. And A is the transparent quartz. It is the transparent quartz window that is sealed onto the glass tube, and ultraviolet radiation pass through the irritation of photosynthetic plate, that is denoted by C. When it passes through it, thus the polarity of the plate C and A are reserved as commutator, and thus the plate A can be maintained as desired positive, and the photosynthesis and is C matter C, and where the corrector plate A is the positive and respectively emitted plate C, and the electrons are attracted to it. We saw that here. You can see experimental the electrons are attracted through it. So yes is the source, or the monoelectric light from a source is coming, and C is the photosynthetic plate, and A is the collection by a plate. So is the collection by a plate. When it comes like this, it happens, the experiment happens here, and we can see the experimental arrangement of in figure 11.11. So we can study the variation of photocurrent with, we can see the variation of photocurrent by seeing the intensity of radiation, and by frequency of incident ray, and by the potential difference between the plate A and C, and by the nature of the material of plate C. By this we can see the differences in that. Next is the effect of intensity of light on photocurrent. So the collector A is maintained at a positive potential with respect to the emitter C, so that electrons ejected from C are attracted towards collector A. So keeping the frequency of the incident radiator and the accelerator potential fixed, we can say the both are fixed. it is found that the photocurrent increases linearly and intensity of incident ray. So the photocurrent is slowly, it is going to increase. We can see here intensity of light and photoelectric current is going slowly increasing. So effect of potential on photoelectric current. So let us take the plate C and emulate the plate C with the light fixed frequency V and fixed intensity I. So we next vary that positive potential of plate gradual and measure the resulting photocurrent each time. So it is found that the photoelectric current increase the acceleration potential. So it increased the potentiality. We can see, and here the interruption of the observation in terms of photoelectrons is straightforward. All the photoelectrons emitted from the metal do not have the same energy. So all the electrons that emit from the photoelectron does not have the same energy. Some have various energy, and photoelectron is zero when we stop the potential. When it gets the sufficient energy, the photoelectron becomes zero. So K is equal to Kmnx is equal to Kmax is equal to VVO is the formula. So effect of frequency of incident radiation on stopping potential. How it works. So we suitably adjust the same intensity of light. We adjust and light radiation at various frequency and study the variation of the photo collection with the collector plate potentiality. So this is the collector plate potentiality here 11.4 diagram. So here different photo current is going in from different places, but here you can see they are all meeting at only one place. They are becoming one. Note for 11.4 that the stopping potential on from V1, V2, V3, they are the frequency of the order V3, V2, 1. These implies that greater frequency of incident light and greater is the maximum kinetic energy of photoelectron. Consequently, we need greater retarding potential to stop them completely. To stop them, greater potential we need. So the graph shows that what all these graph shows us that is the graph shows us that potential V1 varies linearly with the frequency. So there will be very different potential, and there exists a certain maximum cutoff frequency there exists. And the observation that have two implications. The observation we got is the maximum kinetic energy of potential varies linearly with the frequency of incident radiation, but is independent of its intensity. But they are independent by their intensity. And for a frequency V of incident radiation lower than a cutoff frequency VO, no photoelectric emission is possible even if its intensity is large. If its intensity is also large, no potential energy we can put at some times. So these are the observations. So this can be asked in our final exam, what are the observations we got here. So let's come to the photoelectric effect and wave theory of light. So the wave nature of light was well established by the end of 19th century. The phenomena of interference, diffraction and polarization were explained in the nature they explained. And according to the wave picture of light, the free electrons at the surface of the metal absorbed the radiant energy continuously, and we get the greater the intensity of the radiation, the greater or the amplitude. So next is the Einstein photoelectric theory, energy quantum of radiation. Einstein energy quantum of radiation. So HV, where H is the Planck's constant and V is the frequency of the light. The photoelectric effect on electric absorbs a quantum of energy HV of radiation. So quantum of energy you have learnt in your 11th standard. And Km max HV is equal to minus 0. So more tightly bound electrons will emerge with kinetic energies less than the maximum value, and the Einstein said, and the some of according to 11.12 or according to 11.12, the Einstein photoelectric equation, it depends on linear on v it depends, and v is the frequency of the light, as you know. Independent of intensity of radiation in agreement with observation, and this has happened because of Einstein picture, because the diagram Einstein had made. And quantum radiation by a single electron, the intensity of the radiation is proportional to the number of electron quantum per unit. The electron comes from quantum per unit. Since k max must be non-negative, it should be non-negative negative on the inside. And in this feature, intensity of the radiation as noticed above is proportional to the number of energy quantum per unit area per unit time. And the Einstein picture, the basic elementary process involved in the photoelectric energy is absorbed of light quantum by an electron. This process is instantaneously, it happens continuously, and thus whatever may be intensity, the number of quantum of radiation per unit area per unit time photoelectron emission is instantaneous. It should be instantaneous. Low intensity does not mean delay in emission. Low intensity does not say that it is delay in emission. So here VO is equal to HEV minus T by E is the formula that Einstein found. So till here I have explained. So okay friends, I will explain the next topic in my next video. So till here you understand, I think so. I will explain the next topic in my next video. So till then, take care, have a nice day. Bye my friends, and like the video, comment on the video, and subscribe my channel and coaching center for more video, and share my video with your friends. So okay friends, bye, see you, take care, I will see you in the next video. Till then, take care and have a nice day. Bye friends.